Hello everyone. Welcome back to the second episode of the C++ Learning video series. Hope you all are doing good. Before starting, first of all, I will thank you all for your feedback and support in my last video. So now, without wasting any more time, let's begin. In this video, we will target to cover the following topics. First, using comments and commenting style in C++. What are the variables and its different types in C++? Then scope of the variables. Then, what are the keywords used in C++? And finally, the hash-defined preprocessor in C++. So now let's begin with the first one, that is commenting style in C++. Now, let's consider a scenario that one programmer wrote a code implementing his logic, and then he shares his code with someone else who want to use or refer his code. But in case if the logic implemented in that code is a bit complex or the code contains many submodules, then it is not easy every time for the new programmer to understand the logic that the earlier programmer had implemented in his code. So here comes the necessity of comments. Like all other language, C++ also provides us the option to introduce some small comments within our code where it is required. This will make our code more readable and explanatory if someone uses our code in the future. And it is also a good coding practice. But always keep in mind that comments should be as short as possible, else the code will not look good. Comments are only for our comfort for coding, and it will never get executed by the compiler. Means compiler will ignore the commented part while going through the code. One more benefit of using the command is that suppose we are working on some part of the code and it is not yet completed and we have to release one version of the software. We also don't want to delete that uncompleted logic from the code. So what we can do, we just comment out that part of unfinished logic in the code, compile it, and releases our code. In this way, our compiled code will not get affected by that unfinished logic present in the code. And in the next version of the software release, we uncomment that part, complete the same, and then release the new version. C++ support two types of commenting style: single line comment and multiple line comment. Let's have a better look from a code snippet. For this, we need to go to our code editor. Let me open that one. Let's start with hash include IO stream using namespace std. In name argument is void. Cout. Hello everyone. Line break. Cout. Printing line 1. Line break. Cout. Printing line 2. Line cout. Printing line 3 and exiting. Not required. Return 0. Let me zoom the code for better visibility. Now it's good. Now first compile the code and see what is the output. It is running the code. Let's wait. Okay. Now it's compiled and here is our output. It is printing the first line, hello everyone. And then second line, printing line 1. Then third, printing line 2. Then fourth, line 3 and exiting. Okay. Now we have to put the comment in our code. First we start by putting a small explanatory comment in the code. Let me show you how to do this. Suppose at this point we need to add a comment. Our comment should start with a double backslash and then our comment note. For example, we start with this one and our note. This is just a demo code. That's it. And this style is used for single line comment. There is also other way of commenting by enclosing our note within the backslash and the asterisk symbol, like this one. We start with backslash, then asterisk, then the note. This is one more comment line. Then we have to close this in this style, first asterisk and then again backslash, sorry, then backslash. And this style is used for multiple line comment as well as single line comment. Now let's first compile the code and see the output. It's compiling. Okay, now here is the output. And if you see, the output is very much similar to the previous one. It means that the comment we have just added is not executed by the compiler. It's only for our use. Now let's try with commenting the line from the existing code. First we clear the terminal output. Okay, now let us suppose we don't need this line, printing line 1, to get executed by the compiler. So we can put this line as a comment. So we can use here a single line comment, that is double backslash. That's it. And now this line will not get executed by the compiler. Let's check by compiling it, run it, and wait for the output. Okay, now if we see the output, then printing line 1, it is not present here. It means that line is ignored by the compiler. Now, if we require to comment the multiple line in our code, for example, line 7 to line 9 should not get executed by the compiler and should not be present in the output. So we can do this by using the multiple line commenting style. So we can put this like here slash asterisk and end of this line asterisk and slash. Now these three lines will get ignored by the compiler in the final output. So if we check the final output by compiling the code, then it is as, okay, here is the output. It is printing only the line 3 and exiting this one. So in this way, we can use the comment in our code. Hope now commenting style in C++ is very much clear to all. Now moving to our next topic, variables and data types. Data types are generally used to classify or determine the type of data that we are using in our code. Data types are categorized into two types. The first one is primitive or predefined data type, And the second one is user-defined data type. Primitive data types are those data types that are predefined in the C++ library. Examples of primitive data types are integer, character, boolean, floating point, void, etc. User-defined data types are those data types that are not pre-built in the C++ library, but it is defined by the user while coding. Examples of user-defined data types are classes, structures, union, and enum. I will also prepare a separate video to explain these in detail. Now coming to variables, we can define variables as a name reserved memory location for storing the values. It means that we can create a variable and reserve some space in the memory. The space of the memory which we reserve for the variable depends on the data type and the range of the value that can be stored within that memory location. For example, variable of type integer or floating point is of 4 byte. Character or boolean is of 1 byte. So short is of 2 byte. Long is of 8 byte and so on. Variable name is composed of letters, numerics, and underscore. Also, variable names are case sensitive. It means that two variables name, one with uppercase and another with lowercase of the same character, will represent two different variables. After defining the variables, we can further perform various set of operations like addition, subtraction, multiplication, etc. into these variables. Let's check the example of variables and data type in the code snippet. We will go to our demo code which we had written in our last video. Let me open that one. Now coming here to line 6. Here, this line. Int a is equal to 0. In this line, int is the keyword which represent the predefined data type, that is integer. And a is our variable of type integer, and we are assigning the initial value 0 to it. After that, we can use this variable further in our code in different operations. Now, I will also define some more variables here of different data types. Let's start with, suppose, float b equal to 10.5, char name equal to a, then bool result equal to true. Int a equal to 12. Close this one. Also, I forgot to close this one. Let's close this one. Now, these are the new variable which we have defined. First one is b. It is of type floating point, and we give the value 10.5 to it. The next one is name. It is of data type character, and we assign the value a to it. The next one is result. It is of type boolean, and we give the value true to it. Our next variable is capital A, and it is of type integer, and its value we assigned is 12. Now we will compile and check the output of this code. But first I will make some more small changes. Let's comment all these lines. And we will just print the output of our variables. Out value of a is A, new line character. I will copy this one. One more, one more. Value of B is name is name, result is result, A is A. This new line is not required here, just remove it. Okay. Now first in the terminal CLS, then run the code. Just wait for it. Okay. Now here this is the output of all the variables. So in this way we can define and use the variables in our code. Hope data type and variables are now very much clear. Now we will move to our next topic, that is scope of the variables. There are mainly two types of the variable scope. One is local and another is global. Local variables are those variables that are defined inside a block or a function. The lifetime or visibility of these type of variable is only within that function. Once the control of execution comes out of the scope of the function, these local variables are destroyed and cannot be accessed outside the function. Global variables are those variables that are defined outside the function but also are visible or accessed from inside the function. Let me make it more clear with a code example. We will go to our code editor, create a new file here. Starting with hash include IOStream using namespace int main void we will define a variable here int a equal to 100. We will just print this variable value of a is a, close it, return 0. So here we define the variable a inside this function main. So this variable is known as the local variable of this function. We can put a comment here, local variable. Now if we run the code, then our output is, let's wait for it, our output of the value of variable a is 100. Now, if we define this variable outside this function, suppose here in a equal to just 200, then this place, it is known as global variable. We can put the comment as global variable. Again, run our code and check the output is printing 100. But if we comment out the declaration of local variable and run the code, then now it will print the value of global variable. It means this variable is now also accessible from within this function. So in this way, we can define the scope of the variables in our code. Now moving to the next topic, that is keywords in C++. Keywords are the reserved words that are predefined in the C++ library. These play a very important role in writing our code. Let me give you a simple example from our everyday life to explain the keywords. Suppose we are building a house, then what will be a basic and very important material in building the house? It's the brick. We create the wall of the house brick by brick. Now consider this brick as the keywords in writing our code to build the complete software. It is like the building block of our codes. These keywords are predefined in the C++ library, and I think it's around 90 to 95 in total. Looking into the example, the keyword of type integer is int, boolean is bool, character is char, and also there are others like if, while, for, true, false, void, etc. Also, one point we should keep in mind that while creating our variables, we should not give the name of the variable similar to that of the keywords, else the compiler will throw an error while compilation. Let's jump back to the code and see what keyword we have used there. Now here, if we see, we have used the keywords like int, using, return. And in the last program, we use the keywords like int, float, char, bool, true. These all are the predefined keywords in the C+ library. Now moving to our next topic, that is hash-defined preprocessor. The hash-defined preprocessor is mainly used to create the symbolic constant, and this is also known as macro. It means at the start of the code, we will create a constant symbol and assign some fixed value to it. This value will remain the same throughout the whole code and cannot be changed. Then after that, we can use the name of that symbol in our code wherever it is needed. Now during the compilation process, in the pre-processing phase, the compiler will expand the symbolic constant. Means it will replace the symbolic constant with its actual value at each and every place in the code where it is used, and it will further do its calculation. The syntax or writing style of this precursor is hash define, identifier name, and then its value. Let's check the same in detail with a code snippet. Creating a new file. Yes. We can copy the first two lines from our last code. Copy this one, paste it here. Okay. Now, at this place, we will give the declaration of our hash defined preprocessor. Let's put it as hash define length, its value is 20. Hash define width, suppose its value is 10. Hash define height, its value will be suppose 15. Then we start our main function, main void return 0. We will declare a variable in volume equal to 0. Then we will do the calculation, volume equal to length into width into height. Close it, and then we finally print the result. Cout calculated volume is volume. Now we can run the code and check the output. Run it, wait for the output. Okay, so now it's giving the volume calculated as 3000. Now what we are doing here, we had first defined three preprocessor or macro with the name of length, width and height, and assign the values 20, 10 and 15 to them. The values of these macros will remain constant and cannot be changed from the code. Now inside our main function, we are calculating the volume by just doing the multiplication of these macros name. So while compiler will replace this macro name with their actual values and do the calculation, and then final gives us the output as 3000. So this is all about our hash defined preprocessor macro. Now with this we come to the end of this episode. Hope you have enjoyed this video and learned something from this. If you have any doubts, then please let me know in the comment box. Also, if you like my work, then give me a like to this video, subscribe the channel and hit the bell icon to get the notification of my latest videos. We will continue the same in the next episode. Till then, goodbye and keep learning. This is your friend Shambhu Kashyap signing off.